Hello and welcome to the official demonstration of Team Maverick's project, NeuroMedGraph, a cutting-edge knowledge graph system built for the analysis and visualization of rare neurological diseases. Today, I'll walk you through everything from how we built this system, how it works, and how it paves the way for future intelligent healthcare solutions. What is NeuroMedGraph? NeuroMedGraph is a knowledge-driven platform designed to extract, organize, and visualize complex biomedical relationships from scientific literature, specifically focused on rare neurological disorders. Our system takes in raw research abstracts, uses a local open-source LLM model to extract meaningful triples, like disease treated by drug, and finally stores and visualizes these in an interactive, queryable knowledge graph using Neo4j. Homepage walkthrough. Let's begin with the homepage. As you can see, it's designed with a modern, clean aesthetic, showcasing our brand colors and the NeuroMedGraph logo. Visitors can instantly grasp what the tool does, browse key features, and jump straight into exploring the graph via the Explore Knowledge Graph button. We've included an elegant nav bar, a How It Works section, tech stack highlights, and even testimonial sliders, all powered by HTML and CSS. Behind the scenes, LLM model plus NL to cipher. Now let's talk about the brains of the system. We use the open source FLAN T5 model locally, completely free and API keyless, for extracting knowledge triples from raw abstracts. We cleaned, processed, and saved these triples into JSON. Then comes our favorite part, natural language to cipher translation, with a simple question like, what treatments exist for Fabry disease? Once inside, users can explore graphs for 25 plus rare diseases. Each button on the disease dashboard leads to a dynamically generated, interactive HTML graph. These graphs are fully clickable and searchable, allowing researchers and practitioners to explore connections like symptoms, enzymes, drugs, and genetic causes, all generated from literature. No manual curation, repository walkthrough. Next, let's walk through the GitHub repo. It's neatly modular. Data ingestion handles literature scraping, information extraction, LLM-based triple extraction and cleaning. Knowledge Graph builds and visualizes Neo4j graphs. Front end, the landing page and disease graph viewer, plus helper scripts for merging, cleaning, and exporting JSON data. Everything is documented and version controlled. Architecture diagram explanation. Here's the architecture. At the base, we start with PubMed abstracts. These feed into our LLM extraction pipeline, producing structured triples. These triples are fed into a Neo4j graph database. From there, we generate visualizations using Python and HTML, which are embedded into a front-end website built with vanilla HTML CSS. The user can either explore via direct search, buttons, or even use natural language to query using our NL to cipher translator. Future scope and scalability. Looking ahead, we plan to integrate full text analysis, not just abstracts. Add automated knowledge validation with biomedical ontologies like UMLS and MESH. Enable collaborative editing of graphs. Add user authentication and save fork capabilities. Port this into a fast API or React app for scalability. Integrate multilingual support to scale globally. With this foundation, NeuroMedGraph can become an essential platform for rare disease researchers, pharma companies, and clinicians alike. Final thank you. Thank you so much for watching. We hope NeuroMedGraph inspires the possibilities of hybrid AI systems in healthcare.